All right, so we're going to do a little workshop today, reviewing the Excel skills or spreadsheet skills that you might need in order to do the kind of work we'll be doing in this class. How many of you feel like you're somewhat competent in using a spreadsheet? A couple of you, okay. All right, so I'm using Excel. The basic principles apply to pretty much any spreadsheet you use, whether it's Google Sheets or the Open Office version. They do pretty much the same thing, especially for these kind of functions we'll be using. So I'm going to start with the really kind of basic stuff. So we all kind of have a base level understanding of a few general principles of how it works. And then we'll do some sort of moderately more advanced or intermediate kinds of things. The basic idea of a spreadsheet is it's sort of a combination of a database and a calculator. And it's useful for organizing information because you can put it in cells and move it around, but the real beauty of a spreadsheet is that you can do calculations that are all linked together, and therefore if you just change one input, then it'll automatically update all the other calculations. So it'll be extremely valuable for what we're doing, because once you get your spreadsheet set up, you'll be able to just change one key input, say the latitude, for example, and automatically update all your calculations to reflect, what's going on in those particular conditions. So, at a very basic level, I've got some headings up here I'm going to use as kind of cues for some of the examples I'll be doing. So, one thing we can do is just type a number into a cell. If you want to copy that, you can then grab this little handle over here on the corner and copy it either across. In this case, I'm going to copy it downwards a ways. And it'll usually just copy the same thing. Sometimes it will create an ascending series, but it gives you this little button down here in the corner that lets you choose what you want it to do. So here it just copied. If I wanted to fill series, I could select that, and it'll count. And it's got a couple of other options as well. Another way that we can accomplish something similar, we might not just want to count by increments of 1. We might want to count by some other increment. We could say start with a value in this cell, and let's say I wanted to count by 3s. I could say equals, reference the cell above by clicking on it, and it'll put in the cell coordinates, B2, and I'll say plus 3, and then it returns 4, and then if I copy that, now I've got a series counting by 3s. So you could put really any kind of function in there referencing, a cell above, and copy it, and then replicate that same function on the preceding cells. All right, so I just mentioned references. That's another one of the the key features that you'll find in the spreadsheet. And so let's just say I wanted the exact same values that I had over here in column B in column C. I could just say equals. I'll click on cell B2 here, which is immediately to the left, and now it returns that value there. If I copy this down, now it's still referencing the cell immediately to the left. So we call this a relative reference. That means if I have a reference in this cell that points 1 to the left, and it's a relative reference, every time I put that in an additional cell, it's always going to point 1 cell to its left. And by the same token, if I move that over here, now it's still referencing 1 cell to its left. That also works if I copy and paste. So if I say Command C, Command V there, I get the same thing in any one of these locations. If, however, instead of copying, I drag that reference to a new location, so this is a relative reference, if I drag it over here, now it changes the reference. So it locks it to that point that it was referencing when I've moved it over. So this can be really useful sometimes. By the same token, I could drag it downwards, and now if I copy that, it's still a relative reference, but it's pointing at the cell that's 2 to the left and 1 upwards from that location. So that's really useful a lot of times. This will come up because let's say that you were doing calculations of the solar position for every hour of the day. You're going to have the exact same formula for the altitude of the sun, solar altitude, every single hour, but it needs to point to a different time of day. So if you have a column where you have each hour of the day listed, which you could do kind of like we did over here, and then you have your formula over here and you want to point to that hour, then as you copy that down on the first row, it'll point to the first hour, and the last row, it'll point to the last hour, and automatically do all those calculations for you without you having to manually correlate all of those. In other cases, you'll have some things that don't change. For example, the latitude. If you're in one location and you want to know what the solar altitude every hour of the day is, you're going to have the exact same latitude every time. So you don't want a relative reference to the cell where your latitude is entered, because then you wouldn't always be pointing at the same value. So what you can use in that kind of situation is called an absolute reference. So if we, again, put in a reference, I'll do it over here to the 1 that's in cell B2. Click on that. And then on Mac, if you hit Command T, and on PC, it's F4, it'll put a $ in front of the B and a $ in front of the 2. That's now been changed into an absolute reference. So if I return out of that cell and now I copy that around, it's going to keep on pointing to cell B2 no matter where I take it. All right. Likewise, if I copy that over here, the same thing's going to happen. So in other cases, I might want to keep the column fixed and the row relative, or vice versa, the row fixed and the column relative. I can do that by putting a $ just in front of one or the other. So in this case, let's say I keep the $ in front of the B, so it's going to fix it to column B, but it's going to maintain a relative reference to cell number, row number 2 rather. So now if I copy that downwards, this one's now pointing to row 12, while the first one was pointing to row 2. But if I go over a row, I get the same result because it's fixed on row B and relative, fixed on column B, but relative on the row that it's referring to. And you can do the same with the opposite. If I remove this $ and put one in here, then it will keep the row relative and fix the, keep the column relative and fix the row. If you forget the command, you can always just manually enter the $ as well. You don't have to use that command to set it up. So that's one of the kind of the overview of the really, really basic sort of mechanics of how spreadsheet functions and how it the cells relate to one another through references. Does anybody have questions on that part? All right. So let's look at some of the specific kinds of values we might be dealing with. So one thing that we'll do a lot of is calculations using degree values. We're all used to thinking in terms of degrees. but spreadsheets use radians. Does anybody know how many radians are in one full circle, or in 360 degrees? 2 pi radians makes one full circle. So we have to convert from degrees to radians. All of the calculations within the spreadsheet need to be done in radians, or they're not going to turn out right. Unless you are, we'll talk about this in class when we come to this kind of situation, or actually on the orbital angle is an example where you're taking a ratio of 360 degrees. And so you're just multiplying times 360 there. So you get the right fraction by using the degree value there. But anytime you're doing an operation, particularly a trig function, on a radians value, or on an angular dimension, then it needs to be in radians. So all of your internal calculations within the spreadsheet will be in radians, and you'll want to output degrees whenever you're ready. So I have some example degree values input here. The formula for converting from degrees to radians is you start with an equals, and anytime you start the value in a cell with an equals, that's going to be the signal that there's a function in that cell, and so Excel or the spreadsheet is going to try to do a calculation. So I say equals. I start typing degrees, and it prompts me that I probably want degrees. It enters an open parenthesis here, which indicates that is the target that I want to use as my conversion. I could either enter a value directly, or I could enter a reference. So in this case, I'm going to enter the reference to the cell to the left here. So 0 degrees is also 0 radians. Oh, hold on. I just converted degrees to degrees. Sorry, I don't know what I was thinking. Let's try that again. So I'm going to enter radians. Still got my cell reference in there. That looks better. So we can estimate, all right, we know that a full circle is 2 pi radians, so half a circle would be pi radians. That's the value we got, and 2 pi looks about right as well. If we want to go back the other way, which is what I just did, then we'd enter degrees, convert on the radians, and I'm back to my original value. So when you enter a degree value, generally you'll want to convert that to radians immediately. I usually do that in an adjacent cell, and then all of your references for trig functions and whatnot will go directly to that radians value. And then when I want to see my results in degrees, then we'll just convert it back using this very simple formula. All right, another thing we're going to need to deal with is different formats that you'd use in cells. So a format can be anything from a fill color to a border to a font and things like that. But it also has to do with the way it displays numbers. So if you select a cell and then right-click and go to Format Cells, you'll get a dialog that looks something like this. And main ones that we'd be interested in are number, which displays, it's going to show how it displays the numbers and how many decimal places it displays. Whether you use a 1000 separator, you can choose what kind of 1000 separator you want to use in preferences, and how it displays negative numbers. So I'm going to leave it on that for now. The other that, or the others that we would be potentially interested in using would be probably not going to be doing currencies, but we might be interested in dates, time, percentages, and so on. I'll just enter this one as a currency, just because now if I type a value in here, it's going to show me that number formatted in a way that I can read that it's a currency, and it's got the number of decimal places I entered. So I have a number of cells here that I've already formatted in some of those different formats. So we'll look at what they return. We just looked at that. Percentage. This cell is already formatted to show a percentage. If I do make a reference here, then it's going to display 75%. It's going to behave in a calculation just the way that I would expect it to. It's going to actually use 0.75 in the calculation, but it displays 75% as a convenience for us to read. Dates are a particularly interesting case for us. So this one is formatted in the month, day, year format. And if I look at what the options are there. So it's this one, but you can pick a format, really any format that you're used to looking at. For a date. We'll talk in a little while about why this number equals that date. Time is also an important one to use. Note that we've got this fractional value in here, and when I convert it to a time, it tells me that's 9:35. So the time is actually a fraction of 1 day. So 0.8993 is 0.8993 of a day, which it turns out is the time 21:35 or 9:35 p.m. With time, you're going to want, for our purposes, to pick the 24-hour time format. And generally you don't need seconds, but if you wanted to display the seconds, you could. You can display fractions here rounded to a half if you wanted to. Another important distinction to note is that if a cell is formatted for text, it treats a number as if it's text and not an actual number. So in here, it even took my reference and converted it to text. So if you're ever having an issue with numbers not behaving as you expect, you might double check and make sure that the cell isn't formatted as text. Or if you want to format a cell as text in order to display some numerical values that are explanatory or something like that, then you have that at your disposal to do. Another one that can be a little confusing is scientific notation. The way to read this, if you get a number that's over a certain number of digits, it'll often convert to scientific notation for you if it can't display the entire number. Or if you have this formatted to force it to do that, it'll display this like this as well. So what this means is 3.10, the E plus means times 10 to the 5th power here. Okay, so we said a second ago that dates are really numbers. So Excel or any other spreadsheet uses a type of ordinal date system. The only difference from the ordinal dates that Excel uses and what we're doing is the baseline beginning of that process. So most of the time you'll find your spreadsheets are set up to use 1900 as the basis value, the 0 value, January 1st, 1900. Sometimes if you're using a Mac, it used to be the default. It seems like they've changed the default in some of these more recent versions of Excel, but occasionally you'll end up with a 1904 date system. And for some reason, January 1st, 1904 is sometimes used as that base date. It's useful to know what date it is that you have set in your spreadsheet, and it's probably best to stick with the 1900 date system so it's cross-platform compatible. You can go in and look at the preferences, or a very easy way to figure it out is to format a cell as a date, enter 0 in an adjacent cell, and then if I say equals, make a reference to that cell, it's going to tell me that my base date is January. Actually, I think it's I think January 1st is ordinal day 1. So this is saying the 0 day of January 1900. It's not actually a real day. Is the basis of my date system. So one easy way to convert a current date into an ordinal date is to subtract the last day of the previous year from the current date. So the date today is June 5, 2020. So this cell is formatted as a date to display the date properly. This one is formatted as a number. And it's telling me that February 5th, 2020 is ordinal date 43,866. So if I want the ordinal date starting from January 1st, I just need to enter the last day of the previous year. In our case, that is $12/31/19, and so this cell is performing a very simple operation on it. It's just subtracting cell R10 from cell R7. Now it's telling me that it's ordinal date 36, which works because we haven't hit the end of February yet. We happen to be in a leap year this year, and that'll throw our ordinal date calculations off. So generally I'd recommend not using leap years in your calculation. So we'll just assume that we're in 2019 for these purposes, and last year was 2018. You could even, if you wanted to, assume that you were in the year 1900. But regardless, that gives us ordinal date 36, but sets us up so that when we get further on in the year, for example, on the March equinox, then we have the right ordinal date there. Otherwise, we'd be off by a day. All right, is everybody tracking up to there? I have questions on that?
Below, could you click on cell R8?
This one. Can you see that? It's referencing cell R7.
Oh, I see, it's formatted as number.
Yep, so it's just formatted as a number. It shows 2 decimal places, which isn't necessary. And then this one is formatted as the date.
Gotcha.
So, I guess my question would be, why don't you just use the subtraction function to control the dates and use it for a specific year? Like, because you can subtract dates in Excel anyway, right? So why wouldn't you just set it up as a subtraction?
You mean in one cell enter date A minus date B?
Just use it as a reference and paste it as a sequence. Like, use the initial date as a reference and then paste, like, subtract from, basically reference the same point for subtraction.
Well, generally what I would do in practice is, you want one cell where you can enter the date, so you're not always having to fuss around with, you can do it however you want to. I'm not going to prescribe how you set these things up. the reason I do it this way is that I want to have one cell where I can just enter the date without having to think about, just selecting part of the values in the cell and so on. And yes, you can get it to extract the year and then automatically append December 31st of that, year minus 1 to that. So you can get a little fancier if you want to. I'm just kind of giving you the most basic functionality here. All right, so I mentioned latitude a minute ago because it's a good example of something that you'll deal with a lot, and you'll generally just have one fixed latitude for any group of calculations that you're doing, and you want one central place. That value will get used many, many times in different locations in the calculations. So it's nice to have it set up in such a way that makes it really, really easy to do that. So one thing I generally do, it's just a formatting preference thing, but you can set these up however you want to. I like to really clearly distinguish what the input cells are and what the calculation and output cells are, so I know which ones I can modify and which ones that I'll be messing up the model if I go in and modify. So I usually give it some kind of special formatting, give the cells that I intend to put inputs into some kind of special formatting. Excel has some predefined formats, and they call this one input, and you can just click up here and select whichever one you want. They don't have any function other than just a kind of visual alert for you. So I'd prefer to be able to enter my latitude in degrees, so I don't have to convert it to radians because I can't think in radians very well, and I'm generally going to have the degrees available to me. So I'm going to enter it in degrees. I'd usually put a note next to it. It's really helpful to keep track of your units. It's really the only way I've found to be able to really track through what you're doing. So I would keep a cell to just enter a notation so I know what the value is, and then here I'm immediately converting to radians. So we talked about absolute references as well as relative references, and that would be one way to handle this, is putting an absolute reference into this cell that's used wherever you're doing a calculation with it. But for something you're using a whole lot of times, that gets somewhat cumbersome, and it also gets harder to track what you're referring to. So sometimes it's helpful to have a name in there for that cell. And there are two ways you can do that. I've actually already got this one named, but one is that you can go type in this little box up here, and I called it lat_rad. So it's really clear what it is, and I'll know that anytime I see that come up, it's the latitude in radians. And so if this value comes in and changes, well, let's see. Let's just make a formula with that down here. If I just say equal lat_rad, oh, actually, I've got to, hold on. I think I might have that in this one as well, which is not optimal. You really want, I'm going to change the name in this other one so that it's not duplicated. I just called it. Let's try this. There we go. Called it lat_rad2 instead. So now if I enter equals lat_rad2, that cell's formatted as a date, but I'm going to format it as a number. I'm going to just show 2 decimal places. And there it is. And now if I go in and change my latitude, it's going to change the value that appears there every place I reference that in the entire worksheet. So a really great way to be able to quickly insert the same value into various different formulas. Other things, like, for example, let's say the hour angle. in one calculation or one set of coordinates, you'll need the hour angle several times, but the hour angle is also changing hour by hour. So you probably don't want to put a named variable name for your hour angle, because then you'd have to create a new one for every single row where you had an hour, and that's kind of a hassle. But it's relatively easy to use some combination of relative and absolute references to go back to that hour angle, and then when you go down to the next row to do the next set of calculations, then you would update that based on the values in that row.
How did you get that list of all of your newly defined variables?
If you go to Insert, Name, Define Name, that's there. And so if you can also set up a new name, like let's say I wanted to put one for the ordinal date. Go to Insert, Name, Define Name.
Oh, yes.
Yeah. And this one's called, oh, it's actually already called ordinal date. I'll say OK, add a new one. And then you can also remove old ones there. Okay, another thing that's important to understand is how Excel handles fractions or decimal places and rounding. So here I have a number. It happens to be a number that we'll use sometimes, 365 divided by 360. And Excel has found that there are, what is that, about 7 or 8 decimal places that it has calculated this to. By default, I believe it will calculate up to something like 15 or 16 decimal places. We're never going to need that level of precision. It's particularly inconvenient to get these really, really long runs of decimals showing in your spreadsheet, because then it makes things hard to read. They don't line up very well visually, and it doesn't really give us any usable information, because our level of precision is really never going to go past 2 decimal places anyway. But we don't want to actually round off at every step of the calculations, because that's going to introduce error. So on a lot of cells, while you have these, when you have these long numbers, you're going to want to format them so that, what is this referencing? Well, let's actually look at first rounding a value. So this is our actual number. If I increase the number of decimal places being displayed, it's going to look something like this. Oh no, this actually, sorry, this is a different number. So let's take this as our example. If I want to round it off, I can do, or if I want to display it as fewer digits, I can do 2 things. First of all, I can round it. Which to do that, I would say equals round. Select the value, and then select the number of decimal places I want to round it to. And now it's displaying 1.35. If I want to just reduce the number of decimal places displayed, I can also format the cell in order to do that. So here I've got the number formatted to display 2 decimal places, but if I increased it to 4, it'll show me that there. If I took the same number now, let's say, and I pointed to the cell that's displaying 4 decimal places, and I said I wanted to up it to 7, it hasn't lost any fidelity there. It's still actually in the calculations as the full string of decimal places. It's just changing how many is displayed for me. So that was 7. Whereas this one, if I did the same thing, now I'm referencing the rounded value. I've got it formatted to display 7 decimal places, and it's showing me 1.35000000 and so on. So it's actually physically truncated the number and actually rounded it off. So when you go through each step of your calculations, by default you don't have to do anything, but it's going to keep the full string of decimals that it's calculating out to the maximum level of precision in there. And then generally what you'll do is when you get down to the end, you'll want to truncate the display, which rounds off what it's displaying to you to 2 digits most of the time, so that you can more easily understand it. And you can also change that formatting at any step of the way. When you start getting these really long values in tables and whatnot, it makes it really, really hard to deal with. So you can always change that formatting. In a few cases, you may want to actually round it off and use that value in a calculation somewhere. That would be when you'd use the round function. Somebody have a question a second ago? Yes?
Yeah. So does round actually affect the number that's used when the cell with the round function is referenced for another calculation?
Yes.
Okay, got it.
So if I said equals that times 2, oops. Now it's going to be exactly 2.7, and I can test that by referencing it and formatting a cell with more decimal places displayed. And that's the same thing. All right, so let's talk about calculations and functions. So all the arithmetic functions follow the rules that you would expect them to. So let's say I wanted to, just in a cell, if I type some arithmetic in there, equals 2 plus 3, it's going to display 5. Let's put a value in here. If I do the same thing and I use references in that equation, equals x2 plus x3, it's going to give me 8 as well. The arithmetic functions are the normal symbols you would expect, with the possible exception of multiplication, which uses the asterisk. Oops. Oops, equals. That's multiplication. Division uses the right slash. Order of operations also works like you'd expect. You'll use a lot of parentheses. For all bracketing, it just uses nested groups of parentheses. So it's conceptually simple, but with longer formulas, it can get to be really difficult to parse through which parentheses are enclosing which groups of values. So that's another place that if things aren't behaving quite as you expect, that's a good place to troubleshoot, because it's easy to get the wrong numbers of brackets or parentheses in, or have them grouping the wrong elements. But let's say I wanted to say equals 4 plus 3 divided by 4. I'd enter it something like that. Yes?
You have a really long equation with a lot of nested parentheses. Couldn't you potentially just break them down and put them in different cells?
Absolutely.
Right, and then
Yeah.
calculate them in each and then reference.
It takes a lot more space to do that, but yeah, you can definitely do that. And in fact, I would choose to do that in cases where they're really, really long things. Yeah. Then beyond just your basic arithmetic functions, you've got a bunch of others that we can do. Trig functions are one or a group that we'll use a lot. So for example, if I want to take the sine of some value, I just type sine, S-I-N, no E on it, and it'll cue you for that when you start typing it. If you click on there, it will show it to you. So I'd say open parenthesis. If I wanted to just take the sine of some number, I could make a reference to it, close the parenthesis, and then hit return. In pretty much every case when you're using a named function like this, it's going to be followed by parentheses with whatever values it's operating on. I think that's pretty much always true. If instead of making a relative reference like I just did, I wanted to use the named reference that I created earlier, I can type that. And now it will return the value for that, and I'm going to format it to show only 2 decimal places so it's easier to read. So the inverse sign, yes?
Does it assume your input is radians?
Yes.
Okay.
Yeah, so all those calculations, and it doesn't have any way of checking whether you've input radians or not, so it's going to calculate on whatever you give it as if it's radians. So the inverse sign or the arc sign is A-sin, A-S-I-N. I'm going to enter my same variable name there. You can also use these buttons, change the number of decimals displayed. Cosine is COS. And inverse cosine, in all of these, you just add an A in front of it if you want the inverse. So the inverse cosine is ACOS, and tangent is TAN. Inverse tangent is ATAN. Another one that we'll need to do periodically is exponents. You use the function power. And note down here that when it gives you this prompt, it calls these arguments. The first argument, it says number and then power. So these are a good way to remember what you need to enter, because it gets kind of hard to remember the order sometimes. So the first one, number, is going to be whatever value it is that you want to raise to some power. So let's just take the 15 that's in over here, for example. Then we put in a comma. That signals that the next argument is coming up. And let's say we wanted to 15 squared. We would say comma 2, raised to the power of 2, return, and so we get 225. But we could raise it to any power we want. So here's an example of, let's see, a couple of other functions. We already did trig functions, latitude. For pi, there's also a function that will return the value of pi. That should be 90. That is pi, and then just open close parenthesis. You don't have to put in any argument. Pi is fixed at what it is. Like that, and it will return the value of pi for you.
how many decimals can it list?
Probably up to, it's a good question. I don't know. Let's see if we can. I guess, I don't know if that was, is that the full 30? It doesn't look like 30 to me, but,
No, it capped it at,
oh yeah.
you know,
So it's however many that is, 10 or 12, something like that. All right, so if-then functions are another really handy way to do a simple logical test that's useful for example, determining which azimuth equation to use. Remember, we've got a slightly different equation for morning and afternoon. So we could test to see if the time or the hour angle is before noon or afternoon, and then choose the equation to use based on that, for example. So an if-then statement is started with if, comma, and then it tells you, gives you the logical test, then comma, the value of true, and then comma, the value of false. So let's do a test that is, how about we do it on this cell? We say if cell U11, we can say equals. We could also say less than, greater than or equal to, less than or equal to. Let's say if it equals, and then let's use the pi function. If that equals pi, then we'll output some text. I'm putting that in quotes. So the quotes signal that it's text, not a number value. And then let's say it's going to return 0 if it doesn't equal pi. So I've said if this cell equals pi, value of true is, quote, yes, exclamation mark. Value of false is number 0. All right, so it returned yes. So it worked. And let's say I change this to a different number. Now it returns 0. Let's see. I think those are the major things that you need to know in order to do the kinds of calculations that we'll be doing. All pretty straightforward things. The real challenge is coming up with the way to organize all that information and keep track of what it is that you've calculated. So I really would advocate using cells to put in notes about what they are, using the symbols. Generally, I find it, although most people's sort of logical assumption is that when you start putting things in, you want to flow down a column from row to row to row down a column, which works great for one calculation, but I find that it tends to get a little bit cumbersome if you want to repeat those, and that generally I would suggest trying to organize the values in rows. So you flow, like, let's say you're calculating all the values for 1 hour, and at first it'll just be the solar coordinates, but you'll get on to later on looking at relative insolation and other things on that. So you could have one row where all those values appear for that hour, and then you're able to copy all that down and then just change the hour and update all that for the subsequent hour and so forth. Organize it however you see fit, but that's what I've generally found works the best. And so if you have your columns labeled, with the variable name for each one of those values you're calculating, it makes it a lot easier to keep track of that stuff. And also keeping track of, you know, which values are in radians, which ones are outputted to degrees, and so forth. Any questions I can answer for y'all? No? All right. Yes.
I have one. If just visually or graphically, if let's say I'd like to print something out, and I have some half-T fractions, is there a way to format them so they'll get printed horizontally instead of diagonally? Do you know what I mean?
You mean a fraction with like a value slash another value, not a decimal, right?
Right. Or would it be just typing in text in parentheses and draw, you know?
Yeah, you got limited control, to my knowledge, over actual fractions that are input as a number value that Excel can read. You can of course go in and manually format through text boxes or using multiple different cells or whatever you want to. I don't know that you can. No, I think you can tell it what base you want it to calculate a given fraction to. So it will, like in my example, I had 0.54 and it rounded it off to 1/2. But I don't use fractions very much, so I don't have great insight on that.
Just curious.
Sure. Okay, well, great. Thank you. I will see y'all next week.